hopefully everyone can see my web browser screen. I'm currently in Google, okay? And so first thing is, how do we get to the PO.DAAC portal? Just Google PO.DAAC. And in fact, we want to go directly to the Aquarius mission page. So just click there. And if you remember from our from the tutorial and material presented in the first week, the one-stop shop for all types of information, technical documentation, and other data resources relating to the Aquarius mission at the PO.DAAC is this Aquarius mission page. Now, on the right-hand side here, you'll see PO.DAAC tools and services, and we covered some of these things like OpenDAAP, threads, PO.DAAC web services for discovering, accessing, and subsetting data over the web on the fly, a programmatic approach to doing that. But in addition to those, we also have a series of web-based tools for visualization, where you can do these operations through a graphical user interface. So the first tool I'm going to describe is a very simple tool, but nonetheless pretty useful, and it's called the Aquarius Level 3 browser. And all this tool does, it basically provides a visual interface for exploring some of the Level 3 Aquarius datasets, some of the key ones, okay, for salinity in particular. So basically, it's very straightforward. You have a calendar control on the left, and right above it, you have a selector where you basically select the product time interval that you're interested in. Again, these are all salinity level 3 data sets. So now, right now, we're looking at a level 3 daily image for June. Okay, we can use this time selector to basically select any date in that month. Okay, and you can see as I do that, the image is updated here. I can click on it to get a larger visual of it. Okay, and further below, what you see is basically like a film strip of all the images in terms of the daily data for that month. Okay, and you can also basically, rather than using the calendar control, you can just directly click on the item in this film strip display. And likewise for the weekly imagery, let me bring those up. You can see the number of images now are for a given year, so you have 4 per month, and in 2015 you had these many images basically. Okay, and now let me basically, you can use this tool as well to run animations for the time period that's currently displayed. So if I click on this little animation control here, you can see it's stepping through sequentially the images, and you can look at the evolution of salinity patterns globally with this tool quite effectively. You can stop at any point, you can step back, you can step forward, etc., etc. Very straightforward, easy tool to use, for just quickly browsing Aquarius level 3 data, salinity data for a range of time intervals. Again, it's not all time intervals and all data products, it's just some of the key ones. Okay, so this is one of the tools, level 3 browser, and you're welcome to play with that on your own time. Again, you can access it directly by going to the Aquarius mission page and clicking under Tools and Services, Aquarius Level 3 Browser. The second tool that we're going to explore now is called LAS, Live Access Server. It's a tool that is developed by NOAA, okay, and which we host here. It's a widely used tool for displaying earth science data, and we host it here at the PO.DAAC. So when you click on this link, you'll get this page. At this point in time, we've actually just recently upgraded our LAS software to a new version, and that's under user acceptance testing. So we encourage you, in fact, when playing around with this tool, if you do come across any issues with this new version, to drop us an email, and let us know, because again, this tool, this current version of this tool is under evaluation. So anyway, just before I click on the link, I just wanted to point out that at the bottom there's a link to a series of tutorials, okay, on the usage of this tool, okay. So if you're new to LAS, you can basically check out some of that documentation, and that will help you become familiar with the tool. But it's very straightforward. Let's go to it right now. Essentially, again, it's a web-based tool. Now, not only for visualization, but it's a tool for subsetting data, so for basically cutting out portions of the data that you're interested in and extracting that data as a data file that you can then work with locally on your machine. And it's a tool for doing some basic visual analysis. So the first step is basically to choose, as you get prompted here, is to choose a data set. And you do that by clicking on this data set button. And what you get is essentially a list of data sets, okay, Aquarius and other data sets that we have at the PO.DAAC, including various sea surface temperature data sets, the Aquarius data sets, etc. And essentially, you just select one data set that you'd like to review. So let me, for the purposes here, let me just pick the Aquarius CAP sea surface salinity data. You can select any, okay? And this is what comes up. Immediately, you get a map coming up with a global map, and it defaults to the start date of the time series. You can control which day of the image you want to display by making selections in these little time dialog boxes. So let me select another month, and you'll see, okay, nothing has changed, but you'll see at the top right here, you have now update plot button that is red, okay? You can click that, and you see it's spinning its wheels for a minute, and now it's basically run the query on the back end and created a map for the date that you selected. One useful tip here is you'll see this little checkbox, and you want to, in general, you'll want to have that checked all the time. What that means is that basically anytime you do a new selection on the interface, such as picking a new date, it will automatically update the image without you having to manually click the update plot. Okay? So that's a little tip that's useful to know. So a quick orientation now of the user interface. You have the map screen. You have here some information about the query that's been executed to produce this map. You can get rid of that quite simply and maximize the real estate by getting rid of the annotations, okay, or bringing it back. But you see your time controller is still there, so that is not lost. This panel on the right basically allows you to zoom into particular areas of the globe that you want to see an image for. Okay, you want to say, so you can. It's a very straightforward tool. You can basically pan and you can zoom in and zoom out. On the right here, you have some preset areas that you can choose from, and it will automatically zoom into those areas. But let me just pick now sort of the broader Atlantic region here. And you can see automatically, because I have the update plot checked, it's for that date that was selected previously, it automatically zooms into that area and updates that plot. So that's great visually, and you see how fast it actually is as well. Say now I want to, we have the color scale at the top, which tells us what the salinity, what the colors on the map actually represent in terms of salinity values. But we can actually look at the underlying values as well for this subsetted region that we've selected by clicking above here on the toolbar, the Show Values button. Now, there's several things you can actually do in here. You can, in fact, undertake transformations of the values that you can then see those. But let's just do a simple, let's see the raw values from that map. And you see very nicely it produces a tabular matrix essentially showing the data these dots represent null values, and then the actual salinity values are listed above. So through this method, you can basically not only look at the maps graphically, but look at the underlying data values very effectively. But the next thing that users typically want is to actually download the data for a subsetted region of interest locally onto their machine. So there is a button here, Save As. You click on that, and you'll see you have several options. Now, you have already, in the previous screen, selected the spatial area, the spatial domain of the query. This dialog box allows you to modify the time range for that query. So you can extend it. If you want, you can download the entire time series for that region as necessary, depending on your needs. Just for simplicity here, let me just pick a few days. Yeah, we're looking at a 7-day image. So let me just pick, let me just pick this. And here you can control the output format. For the purposes here, let me just select a CSV file because we can browse that directly within the web browser itself. So let me just select that and click Save. And what you see here, because this is a CSV file, okay, it actually comes up in the browser window itself. And so you see the times and the latitude and longitudes for that area that we were previously looking at with the associated salinity values. You'll notice this minus 1 to the power of 34. This basically is a null value, and so when you actually work with these data, you can save this directly, right? You can go File, Save Page As, and you can basically download this data as a CSV file. Basically, when you do your analysis, you want to treat these values as null and not include them in any analysis in terms of computations that you may be doing. Okay, so that's, and again, you can output it as a netcdf file, which you can then work with in Panoply or any other environment such as MATLAB or whatever to do your detailed analysis. So that's the fundamentals of basically subsetting data and inspecting the values and downloading, extracting the values to your machine. One of the nice features of this tool is that it supports it supports graphical analysis of data as well, okay, over the web. So you'll see here right now we're displaying one plot, but there's an option to actually display a panel of up to 4 plots. And so what you see immediately is that it remembers the subsetting region that we were dealing with, and it's brought up the exact equivalent image. But what I can do is I can select for that particular panel here a different date, and you'll see it updates. Let me just see, it does a query. And so you can do visual side-by-side comparisons of the same data set on different dates, or you could select a different variable that's in the data file. In this case, these level 3 data files only have a limited number of variables, some of which are not particularly useful, but let me just, for the sake of argument, do it. And this is the data that's contained in that file. So you can do a comparison variable by variable, but you can totally change which data set you're looking at. I could pick an SST data set. Let me pick wind speed, again, from Aquarius. Close. And so again, for the same time period that I've selected, for the same spatial domain, I can look at a totally different data set and compare values. So this is a very powerful tool, and you can do up to 4 of these panels at any one time. So this paneling feature applies not only to these maps, but to other types of plots that LAS supports. So let me just show you some of these other plot types. It's kind of equivalent to what you guys were doing last week in Panoply. The difference is that this is, web-based. These queries are executed on the fly, okay, and there's no downloading of data necessarily involved. So let me do a simple time series plot now. Let's select a region, okay. With this little control here, I can go to any part of the globe, select a point, and for that spatial area, that spatial location, okay, it will compute a time series of sea surface salinity, because that's what I have selected, for that location, okay? And the nice thing is that you can do, just like we did comparisons before for the maps, you can do comparisons as well for other regions. So let me compare the Pacific with the North Atlantic for the same time series, okay? So you can see how salinity varies at different locations over time. And the nice little thing with this time series capability is you can click on this difference mode button, and what that will do is it will update the plot further to the right. What it has done is taken the initial blue plot that was here and subtracted it from this other time series plot for that other region we had selected, and it plots a time series of differences. So again, you can see how this tool can be used quite effectively to do some basic visual analysis of data. Okay, let me go back to the one plot. So other plots you can do, again, you can do these line plots not only for time series, but you can do them for spatial transects. So I can draw a transect across the Pacific, longitudinally, and get basically an XY plot of salinity versus longitude and how that varies across the Pacific. I can do something exactly equivalent in terms of latitude, okay? And so it works in the same way. Now, another type of plot that is supported by LAS is Hofmüller plots, and you were exposed to those last week. And what these are kind of a combination. Yeah, let me select a slightly smaller area here going across the Pacific. Again, you can basically draw any interactively, and it does the queries and updates the plot on the fly and very quickly, as you can see. So what Hofmüller plots are kind of like time series plots, but in a spatial context. And what you can see here is, just like you had oscillations and periodicities evident in those time series plots that we looked at a few minutes ago, you can see those types of temporal variations in salinity. Oops, excuse me. Okay, so we're back. So you can see those periodic oscillations, but in a spatial context and how they vary with longitude. And what you can see is that the further the further you get to the date line, basically the middle of the Pacific, the less variable salinity is, okay, at that line of latitude over the time series. Whereas as you get further towards near shore, okay, you see much more variability seasonally, etc. So you can see these periodic structures through these Hofmüller plots. You can also see potentially through Hofmüller plots wave-like propagations in salinity. If you see somewhat of some structures in color that seem to progress diagonally across the image, that is suggestive of some kind of periodic organization to the salinity values along that longitudinal line. So this is how you can use these types of Hofmüller plots to, again, do some more careful visual analysis visually through a tool like LAS. And I don't know how I'm doing for time. I think I'm pretty much at the end of my allocated spot. But I think this pretty much covers the full range of functionality of LAS. Just one other thing to mention very briefly is that you can, if you're interested in sharing these displays that you have generated with a colleague or a friend, you can basically click on this link button, and you can basically just send that to them. If they copy and paste that into a browser, they will be able to replicate the exact screen view that you have here. So in this way, you can use this capability to work collaboratively within a team, okay, by sharing links. You can also select to print, and if you right-click and say Save Image As, you'll be able to save this image as a GIF file for use in a report or publication. And with that, I think that concludes really, most of the functionality of this tool. As you can see, it's pretty intuitive to use, so I encourage you to give it a try and let us know how you get on. Thank you.